So, thank you for giving me the opportunity to present existing standards for testing gas phaser cleaners. I'm Paolo Tronville from Politecnico di Torino, Department of Energy. So, first of all, I would like to share with you some information about why are we concerned about performance metrics for measuring the performance of gas phaser cleaners. And the point is that, as a matter of fact, till a few years ago, we didn't have much to use about this. However, we are interested in knowing at least 3 parameters. The first one is the removal efficiency of gaseous pollutants. The efficiency for gas phaser cleaners actually is expressed as breakthrough, that is to say the penetration that is passing through the device. So the efficiency is one minus the penetration. And the kind of pollutant, in case we are interested in supplementing ventilation, is typically a volatile organic compound. So while the standards are covering also other contaminants, in the case of indoor generated contaminants, we are mostly interested in organic ones. The second parameter that is used for assessing the performance of gas cleaning devices is the airflow resistance. This is in some way associated with the cost also of operation. Not obviously, because many times high airflow resistance means lower airflow delivered into the space. So the fan energy use can be correlated to the pressure drop of the device only if there is a device that is actually compensating for the increase of pressure drop, like a variable frequency drive that is actually used to maintain the flow constant. And finally, the third parameter that everybody is interested in is how often people need to change the device or to replace the material that is stored inside of it, so to keep it working properly. This is very critical for gas phase devices because in many cases the pressure drop does not change during the service life, so pressure drop cannot be used as an indicator for the need to replace the device. And fourth, as you can see here, it would be interesting also to know what is the total cost of gas phaser cleaning per unit delivery of VOC-free air. But unfortunately, as of now, we don't have any standard to make this evaluation. So, at least in Europe, the standards that we have available, you can see them listed in these slides. They are all pertaining to the 10-12-1 series. The first one was published in 2013, if it's number 2. And the reason is that it's addressing the performance of full-scale filter elements. And this standard was also confirmed in 2018. While part 1 is covering the part related to the filter material. So in some way it can be seen also as a standard that is interesting for filter manufacturers, because it is possible to evaluate the performance of different types of media. So these two standards actually were published almost at the same time. This one was the part 1 was published in 2014 and then confirmed in 2019. Very recently, you can see here we have part 3 that was published. It was published a few weeks ago, and this is also a very important one because the test methods for assessing the performance of gas phaser cleaning media and devices needs a classification system. Why? Because without a classification system, it is not possible to specify easily what kind of gas phase device should be installed in a ventilation system. In this way, it will be possible to prescribe the minimum performance of the gas phase air cleaning device to be installed to fulfill the expected performance. These standards that I just mentioned were produced by ISO TC 142 and also adopted in Europe as an EN standard, and therefore are available in every country part of Europe and members of CEN. However, the very first standards regarding gas phase cleaning devices were published in the US, the ANSI ASHRAE standard. And the first one that was published in 2008 is the laboratory test method for assessing the performance of gas phase cleaning systems, and especially loose granular media. So these are the pellets that are used to be put into the trays for some specific products. This is a limited scope, because the part one of the previous standard, of the EN standard, is also covering different type of filter materials, while this one is focused on loose granular media only. However, the part two is covering the performance assessment of full-scale filter elements. It was first published in 2011 and then confirmed in 2016 with small changes. And just lately, ASHRAE approved part 4 for a new method that should cover also in duct and chambers apparatus. So it's in this case it will be a so-called multi-pass test method. You may ask why point 3 is missing, and the reason is that point 3, 145.3, was originally thought to be a standard dealing with in situ applications. However, this standard met some problems in developing it, and therefore now it has been basically cancelled, but still, for the sake of avoiding any type of confusion, ASHRAE proposed this as a point 4. In general, we can say that the gas phase cleaners are a bit, I would say, not more difficult, but they are not exactly, it's not possible to rate them in a straightforward way, as it is the case for particulate filter with fibrous media, especially. Well, as we said before, the pressure drop remains the same, so we cannot use pressure drop as an indicator of service life. The filter efficiency in the case of particle filters may increase or decrease, while in the case of gas phase filters it always decreases. So it's also critical to understand when the filter is not operating anymore and therefore should be replaced or maintained in some way. The filter is visibly working in the case of particle filters, so we can see the particles that are captured on the surface of the filter material, while in the case of gas phase filters, except for some cases in which we can see the color of the pellets change, we cannot establish exactly what kind of whether the filter is actually working or not. And last but not least, as I mentioned at the beginning, we do have a few standards these days to assess the performance of these gas phase cleaners, but they are still being developed and are not yet commonly used. So there are not also so many test reports available on these devices and materials. A typical result of a test method is shown in this slide, where you can see the efficiency or the breakthrough. One is a complement to 1 or 200%, and this is typical of an adsorbent filter material, which starts at certain efficiency, and then it will decrease while time passes by. Of course, you can see here the time scale is less than an hour, and this is because the concentration that is used to challenge the filter is very high, much higher than ambient concentrations, and this opens up also other issues that, however, we don't have the time to discuss here. Just to see an example. In general, we can say that in the case of sorbent materials, the features that are part of the filter are the amount of sorbent media. Actually, the amount of sorbent media is very important because, of course, the higher the amount, the higher the mass of contaminant that can be captured and stored into the filter material. And this is also correlated to the so-called residence time, that is to say, the time it takes for the air to pass through the filter bed, typically 0.1 second. The combination of these two characteristics will give what we have just seen, that is to say, the breakthrough or efficiency, and the capacity, that is to say, the amount of contaminant that can be stored into the filter material, which is always related in some way also to the service life, which of course we have to decide how to assess, because there may be applications that cannot accept an efficiency below a certain level, or we cannot accept to have a maximum a concentration that is exceeding a maximum downstream of the filter, or even if the filter itself does not increase its pressure drop, maybe the pressure drop increases because there is a pre-filter or is not correctly pre-filtered, and therefore the particles that are always present in the air will finally deposit onto it. So it's not always easy to understand that. As I said, the current test methods were developed having in mind the traditional gas phase cleaning technologies, so mainly activated carbon or permanganate alumina pellets or fibers or foam, but adsorbents that are able to capture the contaminant to physical or chemical phenomena. These absorption technologies have been used for a long time. They have some pros and cons. However, for sure, the current standards, they have some limitations because they were designed having in mind these type of technologies. New technologies, which include UV lights, UV with the photocatalysts or plasmas, and these also other versions, they needed some different test method, also because they may generate oxidizing agents like radical or even ozone. So ozone generator cannot be considered truly an air cleaner simply because ozone is one of the contaminants of concern. And so even if they break down the contaminants, the volatile organic compounds, the technology must be checked in order to ensure that no harmful substance is released into the airstream and finally enters the occupied space. The work in progress, lastly, we do have in working group 8 of ISO TC 142 a preliminary work item which is titled Testing of Gas Phase Air Cleaners for Improving Perceived Indoor Air Quality, that is based on a different approach from the previous standards. So instead of measuring using an instrument to measure the concentration, the purpose is to assess the quality of the air by perception, by a panel of trained people. This could be based on the document listed here, the ISO 16000-44, that is exactly describing how to perform the measurement of these gas phase contaminants by olfactory tools. And on the other side, we do have also a IEC group, which is working in cooperation with the ISO group, which formed recently a committee, which is SC 59N, and specifically there is a joint working group number 2, whose title is Reduction of Chemical Gases. And in this group, there is a sub-working group on the reduction of ozone, which is, as I said before, a contaminant of concern. So there is a specific group that is dealing with this topic. So having said that, I thank you for your attention, and I'd be happy to take any question you may have. Thank you.